Hello everyone, welcome you all. So in this video we are going to discuss about filter circuits. So what is mean by filter circuits and what are the components which are used in filters. So today in this video we are going to see only basics about filter. So we are not going to design any filter circuit in this, just we will see what is mean by filter and why they are required. So as we all know that rectifiers basically what they will do, they will convert the AC waveform into the DC. So when you put a rectifier here, then it will be converted to a DC. So this is the pulsating DC, means complete DC is nothing but a straight line which is desired, but a pulsating DC means sometimes in between two cycles the output is coming to 0 and again it is increasing. So this is the pulsating component here. So this is not desired in case of DC working components like fan, any other device which you take. So if the voltage is fluctuating, then the motor gets damaged. So in order to avoid that, we are using some filter circuits to get the smooth DC. So after passing through this pulsating DC, when we pass through filter, so let us assume it as F, then we will be getting a smooth DC output, that is called as the filtered DC or smooth DC. So from this to this we want a smooth DC. So that's why the filter circuits are used. So now you have got the idea why we are using filter circuits. So what is meant by filter? The process of getting smooth DC from AC input by using components like capacitor and inductor is called as filter. So by using capacitors and inductors we are creating a smooth DC here. So the process of doing the same is called as filtering. So the circuit which does the work is called filter circuit. So it is seen that the output of a rectifier circuit is not pure DC, but it contains fluctuations or ripple which are undesired. So as I said, the rectifier produces the fluctuating DC, so that is not desired, and in order to avoid that, we are to minimize the ripple content in the output, filter circuits are used. So to minimize the ripple content, that is this content in the output, the filters are mainly used. These circuits are connected between the rectifier and load. So as you can see in the block diagram, the filter is connected between rectifier and the load. So before this fluctuating DC goes to the load, it is converted to smooth DC so that the load can get a minimum harm. So if you see the block diagram, it consists of AC input and it is given to the rectifier circuit. It can be half wave rectifier, full wave rectifier or bridge rectifier. Which one you are comfortable, you can use that one here. Now it consists of DC ripples. So these are the DC ripple output, and that is called as pulsating DC. So it consists of ripples here. So in order to remove these ripples and make the output clear, so we are passing this through the filter. So when it is passed through the filter, at the output or load side we are getting the smooth DC, that is filtered DC output, as you can see in the figure. So this is how the filters are used to get the smooth DC from a pulsating DC or fluctuating DC. So two components which are used in filter circuits are inductance and capacitor. So mainly inductance and capacitors are used in the filter circuits. So not inductance, mainly the capacitor is used as a filter because it charges and discharges. It charges suddenly and discharges slowly. So we are getting some graph like this. So if the input is something like this, then we will be getting some output like this. So it is nearly like a straight line. So because this is the charging, and when it reaches here, the output input cuts off and then it discharges slowly like this. So like this we are